3I Atlas is an interstellar object unlike anything humanity has ever encountered before in our solar system. Recent studies have revealed its nucleus could be larger than 3.1 miles, comparable to the width of Manhattan Island, a size so vast it defies typical comet classifications. This enormous scale alone stuns scientists, especially given that only two other interstellar objects, Oumuamua and 2I Borisov, were ever detected before, and both were significantly smaller. The striking anomaly of 3I Atlas is not only its size but its mass, estimated around 33 billion tons, a figure so massive that it raises questions about its natural origin. Interstellar objects tend to be small, fragmented debris traveling through space, but this one seems robust and dense beyond expectations. Its massive mass combined with peculiar behaviors challenges our understanding of physics and cosmic formation. One mystery lies in its acceleration, a subtle non-gravitational force pushing 3I Atlas beyond what solar radiation alone could cause. Normally, comets change speed only when gases evaporate from their surface, but 3I Atlas moves as if an extra force propels it, hinting at an unknown power source. This observable push opens doors to various speculations about its nature and origin. Scientists detected unusual ratios of nickel and iron in the comet's coma, with a dominance of nickel remarkably high compared to what is found in comets native to our solar system. According to Ailen, a leading astrophysicist, this ratio may indicate artificial origin since such nickel abundance can result from industrial processes on Earth, a detail that further deepens the enigma of 3I Atlas. Despite its colossal size, the nucleus is enshrouded by a dense coma, a cloud of gas and dust extending tens of thousands of kilometers. This coma reflects sunlight and clouds direct observation of the solid core, complicating efforts to measure and understand its true shape and structure. High-tech telescopes like Hubble and James Webb attempt to pierce through this veil to reveal what lies beneath. Every moment 3I Atlas spends near Mars and Jupiter brings new observational insights. Space agencies have mobilized to examine it when it's closest to these planets, hoping to capture clearer images and spectra. These encounters could unveil whether its surface contains ice, rock, metal, or something else entirely, information crucial for solving this cosmic riddle. The path of 3I Atlas is a journey out of our solar system, but its peculiar behavior while here has wider implications. Its approach to the Sun and nearby planets might influence magnetic fields, space weather, or even provoke tiny perturbations in planetary atmospheres. Scientists keenly monitor these secondary effects, uncovering interactions previously unknown in planetary science. Speculation about whether 3I Atlas carries a message or serves as an alien probe adds a tantalizing layer to the mystery. Could it be a deliberate visitor, programmed to study or even communicate with advanced civilizations? If so, humanity stands at a crossroads: how to interpret and respond to such unprecedented signs. Studying 3I Atlas pushes human technology and scientific inquiry to their limits. Observatories scramble to maximize every fraction of data gathered during its brief sojourn in our solar system. This race embodies humanity's relentless pursuit to decode cosmic secrets and perhaps to understand our own place among the stars. In essence, 3I Atlas is a cosmic wake-up call, a mysterious, massive enigma that disrupts old narratives and beckons us toward new realms of possibility. It challenges assumptions, inspires wonder, and holds keys to questions humanity has asked for millennia. Are we alone? What else exists beyond our solar system? And how much do we have yet to discover? 3I Atlas is a cosmic anomaly, a mysterious visitor from the depths of interstellar space that has captured the fascination and curiosity of astronomers worldwide. When first detected in early July 2025, it was immediately clear this was not an ordinary object. With an enormous size and a host of unusual characteristics, 3I Atlas challenges every assumption we have about the nature of comets and asteroids, opening the door to mysteries that blur the lines between natural phenomena and technological artifacts. At the heart of 3I Atlas is its nucleus, the solid core that drives its existence. While typically, comet nuclei wobble somewhere between a few hundred meters to a few kilometers in size, 3I Atlas breaks the mold. High-resolution images from the Hubble Space Telescope place its diameter somewhere between 0.3 and 3.5 miles, with some missions suggesting even larger possibilities. This size range exceeds that of previously known interstellar visitors, marking it as a leviathan among cosmic wanderers, a city-sized iceberg drifting through the void. Surrounding this nucleus is the coma, a luminous halo of gas and dust. The coma forms as sunlight heats the comet's surface, causing ices to sublimate and release gas that drags dust particles along, creating a glowing cloud. For 3I Atlas, this shimmering envelope is especially bright and expansive, a visible beacon in the night sky that has drawn the gaze of observatories around the globe. The dust and gas within this halo carry vital clues about the comet's composition, origins, and the physical processes active on its surface. Scientists analyzing the spectral signatures of 3I Atlas's coma have uncovered astonishing chemical anomalies. The comet is unusually rich in carbon dioxide, with lesser amounts of water vapor, carbon monoxide, and carbonyl sulfide detected. But most startling is the presence of atomic nickel vapor at levels far exceeding those found in most solar system comets. Even more intriguing is the almost complete absence of iron vapor elements typically found together in comparable quantities. This iron-to-nickel imbalance is an eerie fingerprint that could hint at a material origin unlike any natural comet we know. The dynamics of 3I Atlas are equally puzzling. While comets generally slow down or speed up predictably as they interact with the Sun's gravitational and radiation fields, 3I Atlas exhibits subtle accelerations unaccounted for by known forces. These deviations have led some to speculate on the presence of an internal propulsion system or other artificial mechanics quietly influencing its trajectory. Such speculation is supported by the comet's unexpected flares and emissions, some of which occur without clear natural triggers. These mysterious bursts of light and energy, sometimes rhythmic and at other times irregular, have set the scientific community abuzz. Electromagnetic emissions detected near the comet show patterns that differ significantly from well-understood natural sources. Although conclusive proof of artificial signals remains elusive, the possibility that 3I Atlas might carry some form of communication device or sensor payload stoked the imaginations of those engaged in the search for alien intelligence. Adding to the intrigue is the sheer speed and orbit of 3I Atlas. It approaches and will eventually recede from our Sun on a hyperbolic trajectory, indicating it is not bound to the solar system but truly a visitor from interstellar space. Its speed, nearly double that of typical solar system objects, points to an origin billions of miles away, from distant stars or even other galaxies. Embedded within its path are stories of cosmic evolution etched in ice and metal, providing a fleeting glimpse into environments long extinguished but preserved in the comet's very fabric. NASA, the European Space Agency, and observatories worldwide have mobilized to observe 3I Atlas closely as its path brings it near Mars and beyond. The scientific community is leveraging every instrument available: space telescopes, ground-based arrays, and robotic probes to capture the comet's every nuance. This unprecedented international collaboration reflects the object's significance, marking a moment of profound unity in humanity's journey to understand the cosmos. Despite intense scrutiny, 3I Atlas holds fast to its secrets. Sometimes its brightness fluctuates unexpectedly, hinting at fragile surface conditions or internal structural shifts. There are concerns about potential fragmentation, similar to that observed in previous comets, which could scatter more clues into space. Each observation presents new puzzles about material strength, outgassing patterns, and the processes by which such a giant traveler survives interstellar space. The chemical anomalies, especially the nickel abundance alongside fleeting electromagnetic phenomena, have led to intense debate among astronomers and astrophysicists. Could this be an artifact, remnant technology, or material from an alien civilization? While some researchers caution against rushing to conclusions, the unrelenting accumulation of evidence demands consideration of alternatives beyond classical comet science. This extraordinary divergence forces a reassessment of what cosmic bodies can be. The impact of 3I Atlas on the broader field of astrophysics and planetary science is profound. Its presence urges the reassessment of planetary defenses, space weather models, and infrastructure readiness for unexpected cosmic visitors. Scientists speculate on subtle interactions the comet may have with planetary magnetic fields, spaceborne radiation, and even solar dynamics. Each interaction, no matter how slight, could add pieces to the grand puzzle of understanding not just 3I Atlas but the very environment of our solar system. This visitor from beyond the stars also raises urgent questions about humanity's place in the cosmos. If 3I Atlas harbors intelligence or technology, what does it mean for us? How will we respond, and what safeguards should be in place? These questions transcend science, touching on philosophy, security, and the future of human civilization as it reaches ever outward in both technology and imagination. Interstellar comets like 3I Atlas might be nature's way of delivering messages across the void, carriers of cosmic information encoded in their very structure or emissions. Scientists explore methods to decode any potential signals hidden in radiation bursts or surface patterns. The quest moves beyond simple observation toward active listening, a search for reason, pattern, and purpose in the great silence. As 3I Atlas journeys on, leaving spectral traces and disturbances in its wake, its story becomes a beacon of human curiosity and hope. It is a challenge to current technology, a call to innovate and explore. It is a symbol of unity, with nations and institutions joining forces under a shared goal to understand what this massive, wondrous visitor from the depths of space represents. More than ever, 3I Atlas invites us to reflect on the cosmic oceans through which we journey. Its secrets propel us to imagine new possibilities, giving shape to ideas once confined to science fiction. The object itself becomes a cosmic mirror, reflecting our deepest questions about origin, existence, and destiny. Each new observation is a step forward into the vast mystery that is our universe. In the end, 3I Atlas is not simply a comet or a rock. It is a message, a riddle, a testament to the unknown. It pushes humanity to expand scientific frontiers, embrace uncertainty, and dream boldly. Its passage marks a memorable chapter in our quest to comprehend the cosmos, a chapter rich with intrigue, discovery, and the quiet promise of truths waiting just beyond our grasp. 3I Atlas is a cosmic anomaly, a mysterious visitor from the depths of interstellar space that has captured the fascination and curiosity of astronomers worldwide. When first detected in early July 2025, it was immediately clear this was not an ordinary object. With an enormous size and a host of unusual characteristics, 3I Atlas challenges every assumption we have about the nature of comets and asteroids, opening the door to mysteries that blur the lines between natural phenomena and technological artifacts. At the heart of 3I Atlas is its nucleus, the solid core that drives its existence. While typically, comet nuclei wobble somewhere between a few hundred meters to a few kilometers in size, 3I Atlas breaks the mold. High-resolution images from the Hubble Space Telescope place its diameter somewhere between 0.3 and 3.5 miles, with some missions suggesting even larger possibilities. This size range exceeds that of previously known interstellar visitors, marking it as a leviathan among cosmic wanderers, a city-sized iceberg drifting through the void. Surrounding this nucleus is the coma, a luminous halo of gas and dust. The coma forms as sunlight heats the comet's surface, causing ices to sublimate and release gas that drags dust particles along, creating a glowing cloud. For 3I Atlas, this shimmering envelope is especially bright and expansive, a visible beacon in the night sky that has drawn the gaze of observatories around the globe. The dust and gas within this halo carry vital clues about the comet's composition, origins, and the physical processes active on its surface. Scientists analyzing the spectral signatures of 3I Atlas's coma have uncovered astonishing chemical anomalies. The comet is unusually rich in carbon dioxide, with lesser amounts of water vapor, carbon monoxide, and carbonyl sulfide detected. But most startling is the presence of atomic nickel vapor at levels far exceeding those found in most solar system comets. Even more intriguing is the almost complete absence of iron vapor elements typically found together in comparable quantities. This iron-to-nickel imbalance is an eerie fingerprint that could hint at a material origin unlike any natural comet we know. The dynamics of 3I Atlas are equally puzzling. While comets generally slow down or speed up predictably as they interact with the Sun's gravitational and radiation fields, 3I Atlas exhibits subtle accelerations unaccounted for by known forces. These deviations have led some to speculate on the presence of an internal propulsion system or other artificial mechanics quietly influencing its trajectory. Such speculation is supported by the comet's unexpected flares and emissions, some of which occur without clear natural triggers. These mysterious bursts of light and energy, sometimes rhythmic and at other times irregular, have set the scientific community abuzz. Electromagnetic emissions detected near the comet show patterns that differ significantly from well-understood natural sources. Although conclusive proof of artificial signals remains elusive, the possibility that 3I Atlas might carry some form of communication device or sensor payload stoked the imaginations of those engaged in the search for alien intelligence. Adding to the intrigue is the sheer speed and orbit of 3I Atlas. It approaches and will eventually recede from our Sun on a hyperbolic trajectory, indicating it is not bound to the solar system but truly a visitor from interstellar space. Its speed, nearly double that of typical solar system objects, points to an origin billions of miles away, from distant stars or even other galaxies. Embedded within its path are stories of cosmic evolution etched in ice and metal, providing a fleeting glimpse into environments long extinguished but preserved in the comet's very fabric. NASA, the European Space Agency, and observatories worldwide have mobilized to observe 3I Atlas closely as its path brings it near Mars and beyond. The scientific community is leveraging every instrument available: space telescopes, ground-based arrays, and robotic probes to capture the comet's every nuance. This unprecedented international collaboration reflects the object's significance, marking a moment of profound unity in humanity's journey to understand the cosmos. Despite intense scrutiny, 3I Atlas holds fast to its secrets. Sometimes its brightness fluctuates unexpectedly, hinting at fragile surface conditions or internal structural shifts. There are concerns about potential fragmentation, similar to that observed in previous comets, which could scatter more clues into space. Each observation presents new puzzles about material strength, outgassing patterns, and the processes by which such a giant traveler survives interstellar space. The chemical anomalies, especially the nickel abundance alongside fleeting electromagnetic phenomena, have led to intense debate among astronomers and astrophysicists. Could this be an artifact, remnant technology, or material from an alien civilization? While some researchers caution against rushing to conclusions, the unrelenting accumulation of evidence demands consideration of alternatives beyond classical comet science. This extraordinary divergence forces a reassessment of what cosmic bodies can be. The impact of 3I Atlas on the broader field of astrophysics and planetary science is profound. Its presence urges the reassessment of planetary defenses, space weather models, and infrastructure readiness for unexpected cosmic visitors. Scientists speculate on subtle interactions the comet may have with planetary magnetic fields, spaceborne radiation, and even solar dynamics. Each interaction, no matter how slight, could add pieces to the grand puzzle of understanding not just 3I Atlas but the very environment of our solar system. This visitor from beyond the stars also raises urgent questions about humanity's place in the cosmos. If 3I Atlas harbors intelligence or technology, what does it mean for us? How will we respond, and what safeguards should be in place? These questions transcend science, touching on philosophy, security, and the future of human civilization as it reaches ever outward in both technology and imagination. Interstellar comets like 3I Atlas might be nature's way of delivering messages across the void, carriers of cosmic information encoded in their very structure or emissions. Scientists explore methods to decode any potential signals hidden in radiation bursts or surface patterns. The quest moves beyond simple observation toward active listening, a search for reason, pattern, and purpose in the great silence. As 3I Atlas journeys on, leaving spectral traces and disturbances in its wake, its story becomes a beacon of human curiosity and hope. It is a challenge to current technology, a call to innovate and explore. It is a symbol of unity, with nations and institutions joining forces under a shared goal to understand what this massive, wondrous visitor from the depths of space represents. More than ever, 3I Atlas invites us to reflect on the cosmic oceans through which we journey. Its secrets propel us to imagine new possibilities, giving shape to ideas once confined to science fiction. The object itself becomes a cosmic mirror, reflecting our deepest questions about origin, existence, and destiny. Each new observation is a step forward into the vast mystery that is our universe. In the end, 3I Atlas is not simply a comet or a rock. It is a message, a riddle, a testament to the unknown. It pushes humanity to expand scientific frontiers, embrace uncertainty, and dream boldly. Its passage marks a memorable chapter in our quest to comprehend the cosmos, a chapter rich with intrigue, discovery, and the quiet promise of truths waiting just beyond our grasp. 3I Atlas continues to defy expectations as new research unfolds, revealing layers of complexity that deepen the mystery. Every observation brings more questions than answers, challenging not only our scientific instruments but our very understanding of the cosmos. Its presence in our solar system is both a rare gift and a profound puzzle, beckoning humanity to look beyond traditional boundaries and embrace the unknown. One of the most striking facts about 3I Atlas is the extraordinary abundance of heavy metals detected within its coma. Scientists have observed an extreme ratio of nickel to iron, with nickel appearing in quantities far greater than typically found in native solar system bodies. Such a chemical signature is unusual and has no easy natural explanation, leading researchers to consider scenarios involving either unique cosmic formation processes or possible extraterrestrial metallurgical activity. The extreme nickel presence might suggest that 3I Atlas is composed, at least partially, of processed materials rather than primordial cosmic dust and ice. In the context of known natural bodies, elements like nickel and iron are usually distributed together because they form under similar conditions in stars and planets. The decoupling of these metals within this object challenges established astrophysical models, hinting at a story not yet understood, one that may even include artificial or engineered origins. Scientists employing state-of-the-art spectrometry techniques have even begun to detect complex organic molecules, some of which bear striking resemblance to biomolecules essential for life. This raises fascinating implications about the role of interstellar objects as possible carriers of life's building blocks across the galaxy. Could 3I Atlas be a cosmic messenger delivering the raw ingredients or perhaps even the machinery of life between star systems? The idea propels the object from a simple comet to a potential actor in a grander drama of cosmic seeding. The trajectory of 3I Atlas itself is equally enthralling. It moves with an unusual velocity, faster than typical comets influenced solely by the Sun's gravity. This high speed suggests it has traversed interstellar space for millions of years, journeying across the void between stars and carrying with it the history of distant cosmic events. As it approaches perihelion, the closest point to our Sun, its acceleration patterns become even more unpredictable, raising the possibility of unknown forces acting upon it. Such acceleration could be explained if 3I Atlas is outfitted with a non-gravitational propulsion system, a concept that stretches the limits of conventional science. This propulsion might use solar radiation pressure or some exotic technology unknown to our current understanding. The mere possibility invites heated debate and intense scientific scrutiny, effectively transforming the study of this object into a speculative frontier bridging astrophysics and the search for extraterrestrial intelligence. Observations with powerful telescopes such as the James Webb Space Telescope have provided unprecedented insights into the object's surface composition and outgassing behavior. Contrary to expectations for a typical comet, 3I Atlas exhibits remarkably low levels of water vapor, a primary component of cometary activity, while releasing significant amounts of carbon dioxide and carbon monoxide. This atypical gas release profile further sets it apart and suggests a composition that might be more akin to an asteroid or even an artificial body. Meanwhile, the object's coma has revealed sudden and unexplained outbursts, brightening 3I Atlas's glow unpredictably. These outbursts seem to indicate bursts of energy or material release that don't fit known cometary physics. Could these be signals? Or perhaps the result of internal processes, such as mechanisms maintaining the object's integrity while traversing a hostile interstellar environment? These questions remain open, fueling speculation and scientific curiosity alike. Ground-based observatories have reported fluctuations in the comet's brightness, as if it is rotating irregularly or perhaps controlled. Such changes could imply an active surface, where volatile compounds sublimate unevenly, or, more intriguingly, artificial mechanisms adjusting the object's orientation. Each possibility imposes different demands on researchers trying to model and predict 3I Atlas's behavior, underscoring how little we truly understand about it. In dedicated radio observation campaigns, intermittent signals, sometimes rhythmic, sometimes erratic, have been recorded near the trajectory of 3I Atlas. While no definitive association with extraterrestrial intelligence has been confirmed, the mere presence of such emissions marks a departure from expectations for a simple comet. These signals compel scientists to think broadly and explore possibilities including the presence of intelligent design, advanced sensors, or alien communication. The massive scale of 3I Atlas, combined with these anomalous properties, has prompted international space agencies to coordinate observation missions with unprecedented collaboration. From orbiting satellites to ground telescopes scattered across the globe, tracking efforts aim to capture every nuance. This international scientific network symbolizes a human unity inspired by a distant visitor that transcends politics and conflicts to inspire wonder. Political and scientific communities worldwide now face profound questions. What does 3I Atlas represent? If it is artificial, how should humanity respond? Discussions have begun, quietly in the corridors of power and publicly in scientific forums. The implications reach far beyond academia. Political readiness, space law, planetary defense, and ethical considerations come into sharp focus, preparing society for potential realities we have scarcely imagined. The approach of 3I Atlas near Mars and Earth offers a rare, fleeting window into the mysteries of the universe. As the comet passes close to Mars, NASA's rovers and orbiters are tasked with collecting data that could reveal changes in planetary atmosphere or surface conditions caused by this interstellar visitor. Such close interactions may help us unlock clues about both the object itself and how planets react to massive foreign intruders. Beyond Mars, 3I Atlas's path takes it near Jupiter, a mammoth gravitational force that may alter its future journey. Jupiter's strong gravity could affect the comet's speed and trajectory, perhaps even pulling fragments into new orbits. This gravitational dance adds unpredictability to the object's trajectory, complicating modeling efforts but providing scientists a natural experiment to study interactions of massive bodies in motion. Deep space missions are also being proposed to follow and study 3I Atlas beyond the reach of Earthbound and near-Earth instruments. These missions could send probes to collect particles or images up close, providing irreplaceable data. Though ambitious and costly, such missions would represent a monumental leap in humanity's ability to engage with interstellar phenomena, and could set the stage for future explorations far beyond the solar system. The philosophical and existential implications of 3I Atlas are immense. This cosmic traveler challenges long-held assumptions about isolation and uniqueness in the universe. Its nature, whether natural or artificial, forces humanity to reconsider our place in the cosmic arena. If 3I Atlas is part of a larger network of interstellar objects, our understanding of life and intelligence beyond Earth could be profoundly altered. Scientists grapple not only with technical puzzles but with the narrative that 3I Atlas tells about the cosmos. Could it be a relic of civilizations that have risen and fallen long before our sun even existed? Or is it a beacon, a message sent across vast distances to connect with others? These possibilities invite both awe and caution, urging patience, rigor, and humility as we interpret the sparse data available. The role of 3I Atlas in sparkling public imagination cannot be understated. Its mysterious nature combined with enormous size makes it a perfect muse for storytellers, dreamers, and investigators alike. Documentaries, lectures, and discussions spread its story far beyond academe, inviting people everywhere to ponder the infinite and the unknown. Researchers involved in the direct study of 3I Atlas often describe a mixture of excitement and frustration. Limited observation windows, measurement uncertainties, and competing theories all complicate the quest for definitive answers. Yet this challenge is what drives the work forward, invoking a spirit of discovery reminiscent of astronomy's greatest breakthroughs. In the coming months, new revelations about 3I Atlas are expected to emerge as observation technologies improve and data streams accumulate. Each discovery refines models, discards some theories while supporting others. Progress is gradual but relentless, shaping a story that promises to keep humanity captivated for years to come. Ultimately, 3I Atlas is not only a physical object but a symbol of cosmic frontier exploration. It embodies humanity's desire to reach out, to question, and to learn about worlds beyond our own. Its journey through the solar system may last only a short while, but the impact it leaves on science, culture, and collective imagination will resonate across generations. As we continue to watch and study 3I Atlas, we stand on the precipice of one of the most intriguing cosmic mysteries in history. The vast unknown beckons, inviting us to look deeper, think bigger, and prepare for discoveries that may redefine human understanding of space, life, and the universe itself. The story of 3I Atlas is just beginning, and who knows what revelations lie ahead in the cold, silent stretches between the stars? 3I Atlas continues to challenge our understanding of the cosmos with its extraordinary characteristics and enigmatic behavior. Scientists are increasingly drawn to this celestial wanderer, delving deeper into its mysteries as new data emerges. Each discovery adds another layer of complexity, revealing a traveler that is unlike any comet, asteroid, or object we have previously studied, pushing the boundary between the natural and the unknown. One of the most captivating aspects of this interstellar visitor is its resemblance to artificial constructs proposed by some theorists. The idea that 3I Atlas might be an extraterrestrial probe or artifact arises from its size, trajectory, and unusual acceleration. This hypothesis has sparked rigorous debate, as it confronts traditional scientific skepticism with compelling empirical observations that cannot be dismissed easily. Closely examining the motion of 3I Atlas reveals peculiar accelerations that do not correlate with expected natural forces. Its velocity changes are inconsistent with interactions from solar radiation pressure alone or gas jets produced by sublimating ices typical of comets. Such phenomena lead some to speculate that it might possess an internal propulsion mechanism or be influenced by unknown physical forces, possibly of artificial origin. The comet's composition further complicates matters. Spectroscopic analyses reveal metallic and organic compounds in ratios rarely, if ever, observed in known comets. The unmistakable abundance of nickel, coupled with the absence of expected elements such as iron, suggests formation or alteration under conditions foreign to our solar system's typical environment. These chemical oddities present a tantalizing puzzle for astrochemists trying to reconstruct the object's history. Advanced telescopes and spectrometers have also detected transient emissions in various electromagnetic bands coming from the comet's vicinity. Occasional bursts observed in radio, infrared, and even X-ray wavelengths defy straightforward astrophysical explanation. These fluctuations seem to indicate non-random processes possibly related to communication attempts, scanning activities, or unknown interstellar phenomena connected to the object. As we consider the possibility of artificiality, comparisons arise with previous interstellar visitors such as Oumuamua, which sparked similar discussions about its potential as a light sail or probe. However, 3I Atlas' immense size adds a new dimension to the debate, representing a possible technological artifact on a scale previously unimagined. With each successive observation, we are confronted by the profound question: how do we identify and interpret signs of alien technology if, indeed, this is what 3I Atlas represents? The implications of an artificial origin are profound, transcending scientific curiosity to touch upon questions of existential importance. We must consider what it means for humanity to discover evidence, even circumstantial, of advanced civilizations beyond our solar system. How prepared are we to receive such information, and how might this reshape our worldview, technologies, and values in the years to come? Several research teams worldwide are now focusing on these questions, designing observation campaigns and modeling efforts to simulate 3I Atlas' behavior under both natural and artificial hypotheses. These interdisciplinary efforts unite astrophysicists, engineers, chemists, and data analysts in an unprecedented scientific endeavor, demonstrating the fusion of curiosity and rigor that defines modern exploration. The vast distances 3I Atlas has traveled further complicate our understanding. Interstellar space is a harsh environment where cosmic radiation, particle bombardment, and gravitational forces constantly shape objects decaying over millions or billions of years. How has 3I Atlas remained intact, retaining its mass and signs of activity? This resilience could suggest advanced engineering unconstrained by natural degradation. Efforts to model the forces acting on 3I Atlas have led to multiple transport and propulsion theories. One such hypothesis involves solar radiation acting not as a mere push but as an interactive force with possible reflective surfaces on the comet, analogous to solar sails proposed for spacecraft propulsion. If true, this would imply a level of control confirmative of artificiality and advanced technological design. The scientific instruments monitoring 3I Atlas continue to search for electromagnetic signals with patterns that may resemble encoded information. Although no definitive alien messages have been decoded, the search remains active. Efforts to apply machine learning and quantum computing methods to analyze vast data sets reflect innovative approaches, extending our capabilities beyond traditional signal analysis. Understanding the environmental impact of 3I Atlas on nearby planets is another urgent subject gaining attention. Mars, in particular, serves as an observational sentinel. The planet's atmosphere and magnetosphere may interact with the comet's outgassing or electromagnetic emissions in ways previously unimagined, offering insights into both planetary science and the comet's enigmatic properties. Meanwhile, ground-based telescopes continue to track subtle fluctuations in brightness and rotation, capturing signs that may indicate structural complexities or internal dynamics. These observations help scientists infer whether 3I Atlas hosts compartments or subsystems, fostering discussions about the nature of its interior and the possibility of hidden machinery or technology within. Policymakers and space agencies globally are beginning to grapple with the significant ramifications of 3I Atlas' presence. Workshops and conferences dedicated to planetary defense and space security now include scenarios involving intelligent interstellar visitors. This pragmatic shift reflects an evolving understanding and preparedness, emphasizing not merely detection but response and engagement strategies. Culturally, 3i Atlas has ignited imaginations, inspired speculative fiction, and prompted philosophical reflections on humanity's potential contact with extraterrestrial intelligence. The public's awe and wonder intertwine with scientific discourse, creating a unique moment where science meets societal contemplation on a cosmic scale. Emerging technologies may soon allow humanity to dispatch exploratory missions capable of rendezvousing with 3i Atlas or trailing its path beyond the solar system. The technical challenges are enormous, but the prospect of directly investigating an interstellar construct would revolutionize humanity's approach to space exploration and interstellar communication. Meanwhile, ongoing observation campaigns monitor changes in 3i Atlas's surface reflectivity, spectral features, and gas composition, assembling a dynamic picture of its evolving state. Variations hint at surface renewal, possible mechanical activity, or interactions with cosmic rays and solar wind, contributing critical parameters to evolving models of the object's identity. The scientific community wrestles with the difficulties of interpretation in the face of conflicting evidence. As new data supports divergent hypotheses, some argue for cautious restraint, emphasizing the importance of rigorous verification. Others see in 3i Atlas a watershed moment demanding bold reconsideration of extraterrestrial life and the nature of cosmic technology. As humanity contemplates the broader implications, questions about the origin of technological life and the prevalence of cosmic intelligence gain renewed emphasis. The possibility that intelligent civilizations deploy such probes adds urgency to the interdisciplinary study of astrobiology, astrophysics, and planetary science. Ultimately, 3i Atlas embodies the frontier of human knowledge and curiosity. Its secrets traverse not only space but the unknown horizons of possibility. As we continue to observe, analyze, and theorize, this enigmatic visitor invites humanity to expand its quest for understanding, to embrace wonder, and to prepare for revelations that may forever redefine our cosmic narrative. The journey of 3i Atlas through our solar system is brief, but the significance of its visit is enduring. It beckons a new era of exploration and inquiry, where science and imagination converge. In its wake lies a transformed perspective, a widened horizon where the extraordinary becomes tangible, and the universe's infinite complexity unfolds before us in stunning detail. The story of 3i Atlas is, at its core, a story of human aspiration, that unyielding desire to know, to connect, and to find meaning amid the stars. Each observation is a chapter in this unfolding saga, each question a spark igniting the engines of discovery. As we stand on the threshold of this cosmic adventure, we are reminded that the greatest discoveries often arise from the unexpected, the mysterious, and the unexplained. The vastness of space conceals countless secrets, and 3i Atlas shines as a beacon among them, urging us onward. It stands at the crossroads of science, philosophy, and imagination, challenging us to reach further than ever before. With open minds and relentless curiosity, humanity faces the future, ready to unravel the mysteries carried by this extraordinary traveler from the depths of interstellar space. 3i Atlas has offered humanity a rare opportunity to witness an interstellar visitor passing through our cosmic neighborhood, observed by the most advanced tools that modern science has to offer. Since its discovery on July 1, 2025, numerous space telescopes and Earth-based observatories have watched this celestial giant, capturing images and data that detail its composition, behavior, and trajectory. Though fleeting, its presence sparks a deep scientific quest to understand not just the object itself, but what it represents on a cosmic scale. The European Space Agency quickly mobilized its Mars and Jupiter missions to track 3I Atlas from vantage points unreachable by Earthbound observation. As Earth's view became blocked with the comet moving behind the Sun, orbiters around Mars and Jupiter retained a clear line of sight. This critical phase allowed scientists to continue gathering data uninterrupted, using the robotic eyes already stationed near those planets. The strategic use of these spacecraft underscores international cooperation in pursuing cosmic mysteries and harnessing technology beyond terrestrial limits. At the heart of these efforts were NASA's space telescopes Hubble, James Webb, and SPHERX, which observed 3I Atlas through multiple wavelengths. Hubble's July observations captured the comet's nucleus and coma, providing size estimates ranging between 0.3 to 3.5 miles. Webb's infrared data revealed unusual chemical signatures, a surprisingly high abundance of carbon dioxide layered with lesser water ice, carbon monoxide, and complex organics. SPHERX contributed essential spectral mapping, revealing compositional diversity that deepens the intrigue. The comet's activity is far from static. Continued observations revealed the comet's glow growing brighter, and the tail stretching longer as 3I Atlas approached the Sun. Gemini South, a prominent ground-based telescope, monitored this expansion, highlighting a large, diffuse dust cloud that hints at increased sublimation or outgassing from the nucleus. These fiery displays are a cosmic dance as solar radiation teases volatile substances from the comet's surface, animating it with new mysteries with every passing day. Unexpected bursts and fluctuations in brightness hint at unstable conditions on or near 3I Atlas's surface. These fluctuations could indicate rapid discharges of gas, partial fragmentation, or internal turmoils releasing embedded material. The comet's dynamic character evokes vivid images of a distant world bristling with processes both familiar and alien, clues that scientists are eager to decode in pursuit of its true nature and origin. The challenges of observation only intensified as 3I Atlas drew nearer to the Sun. Its position close to the solar glare limits Earth-based viewing, making spacecraft the critical tools of discovery. The comet's close approach to Mars on October 3, 2025, presents a unique opportunity for Mars orbiters to capture high-resolution images and spectra. This proximity not only enriches scientific data but also tests our ability to respond quickly to celestial events across the solar system. Scientists also study the comet's influence on Mars, which, though minor, could inform future planetary defense strategies. Dust and gas emitted by 3I Atlas might interact with the Martian atmosphere or magnetic field, providing natural experiments on planetary responses to interstellar visitors. Monitoring these interactions could shed light on the broader impact such objects might have when traveling through planetary systems. Following Mars, 3I Atlas continues its journey near Jupiter, where the gas giant's immense gravity might alter its trajectory. This interaction could even fragment the object or modify its velocity, adding another layer of complexity to tracking and predicting 3I Atlas's path. Such gravitational interactions are natural in celestial mechanics, but understanding how they play out with an interstellar object remains an active area of research. Ground-based telescopes, although limited by the comet's solar proximity, still contribute valuable measurements. Variability in brightness and coma diameter fuel models of the comet's rotational behavior and outgassing jets. Observers piece together the comet's rotation period and surface heterogeneity, grappling with the challenge of predicting volatile behavior driven by an alien origin and unique environmental conditions. Amidst these empirical pursuits, some of the most imaginative speculation involves signals bursts of electromagnetic energy that might indicate active communication or data collection systems aboard 3I Atlas. While no definitive messages have surfaced, advancements in signal processing and machine learning aid the ever-evolving search for extraterrestrial intelligence, inspired anew by the presence of this formidable and unusual comet. Preparing for the comet's unexpected visitation also galvanizes the policy and space communities. Discussions have widened to include protocols for detecting, monitoring, and, if necessary, responding to interstellar objects that may pose risks or opportunities. The transient nature of 3I Atlas's visit highlights the need for swift scientific response and adaptive strategies in planetary defense, a theme gaining prominence in this era of increasing interest in space. Culturally and philosophically, 3I Atlas has become emblematic of humankind's eternal quest for cosmic knowledge. Its passage sparks reflection on our shared humanity, diversity, and place in the universe. When a visitor from a distant star system briefly graces our sky, it evokes a sense of unity, wonder, and responsibility. Stories, documentaries, and discussions propagate its legend, inspiring future generations to dream about the stars. Upcoming months promise continued revelations as 3I Atlas recedes toward the outer solar system. Though it will dim and eventually disappear from telescopic sight, the wealth of data it leaves behind will generate insights for years. Scientists eagerly anticipate correlating measurements from various instruments to refine understanding of not only this comet but of interstellar phenomena in general. Plans for space missions designed to follow and sample similar objects are being formulated. The potential to intercept or rendezvous with interstellar visitors could profoundly advance planetary science and biology. 3I Atlas serves as a compelling case for pushing humanity's technological boundaries toward direct interaction with celestial strangers. With every new piece of information, 3I Atlas reshapes the boundaries of exploration, science, and human imagination. It challenges us to consider the complexity of the galaxy and the possibility of life and technology far beyond our current reach. Its journey touches not just astrophysics but the very philosophy of existence and connection. Humanity stands at the beginning of a new cosmic chapter, one where 3I Atlas is a torchbearer illuminating the vast unknown. How we respond scientifically, technologically, and ethically will define our future role in the universe. It may be a fleeting visitor, but its imprint on human discovery is timeless, a cosmic invitation to explore farther than ever before. 3I Atlas made its grand entrance into our solar system under the watchful gaze of the Atlas Survey telescope stationed in Chile on July 1, 2025. This discovery sparked a race among scientists and observatories worldwide to trace its path and uncover its secrets before it moved beyond reach. Early observations captured a comet moving at extraordinary speeds over 210,000 km per hour, breaking records as the fastest interstellar visitor known to humankind. Detected initially at a staggering 670 million kilometers from the Sun, 3I Atlas was seen as a faint yet fascinating object, barely visible to all but the largest and most sensitive telescopes. Its journey from the vast galactic realms into the inner solar system was charted meticulously using archived images from several telescopes. These pre-discovery glimpses extended back across several weeks in June, underscoring how silently and swiftly this visitor approached. The designation 3I marked it as the third confirmed interstellar object detected, following Oumuamua and 2I Borisov. But unlike these predecessors, 3I Atlas' hyperbolic trajectory clearly showed it was not tied gravitationally to our Sun. It was a cosmic traveler, just passing through. Its path was not threatening. It would not come closer than 270 million kilometers to Earth, safely distant but tantalizingly close in astronomical terms. Scientists' early debate centered on whether 3I Atlas was an asteroid or a comet. Initial images lacked definitive coma or tail, features typical of active comets. However, soon after, telescopes including the Lowell Discovery Telescope and the Canada-France-Hawaii Telescope confirmed the presence of a faint, diffuse coma and a slight tail-like elongation, hallmark signs of cometary activity. This activation suggested sublimating ices and dust-releasing material as the nucleus warmed. The comet's reddish coma, consistent with dusty debris released into space, resembled features observed in 2I Borisov. This color indicated registered dust similar to primitive solar system materials, but the story deepened as scientists noted changes in the coma's color over time. Over July 2025, the coma grew progressively redder, a sign pointing to evolving surface material composition or increasing activity, as solar energy began to seep into the ancient object. During this time, telescopes worldwide continued to reveal the object's behaviors. Polarimetric measurements conducted by prominent observatories unveiled an unusually high degree of negative polarization in the coma's reflected light at small phase angles. This trait implies the comet's dust is composed of a mixture of ice and darker organic materials, a delicate blend influencing how sunlight scatters off its surface. The more sensitive and powerful telescopes such as the Vera C. Rubin Observatory serendipitously captured 3I Atlas during their early operations. Their data provided constraints on the comet's size and dust emission, revealing a slow but steady increase in the coma diameter. This effective imaging helped calibrate expectations for further observations and underscored the importance of wide-field surveys in detecting fleeting interstellar visitors. NASA's Transiting Exoplanet Survey Satellite, TESS, designed to detect distant planets by monitoring stars' light variations, inadvertently observed 3I Atlas months before its official discovery. These observations confirmed the comet's activity when it was still a distant traveler, roughly 6 for astronomical units away, where most comets remain inert. Detecting activity so far from the Sun suggested exotic volatiles beyond water ice were driving the comet's early sublimation. In September 2025, the James Clerk Maxwell Telescope confirmed the outgassing of molecules like hydrogen cyanide, a marker of complex organic processes in the coma. The measurement showed significant variability in production rates over just a few days, indicating dynamic and vigorous chemical interaction on or within the nucleus. The comet's tail extended impressively, trailing tens of thousands of kilometers, spreading its secrets invisibly throughout space. Moreover, the comet's spectral signatures from visible and infrared studies have painted a picture of chemical diversity. Observations noted a rich supply of carbon dioxide alongside trace amounts of carbon monoxide and carbonyl sulfide, showcasing a complex chemical ballet beneath its seemingly inert exterior. These gas compositions mark differences from typical solar system comets, highlighting its exotic, interstellar origin. As 3I Atlas approached perihelion near the orbit of Mars on October 30, 2025, observational efforts peaked. This close approach provided unmatched opportunities for favorable viewing angles from Mars orbiters such as the Mars Reconnaissance Orbiter and Trace Gas Orbiter. Astronomers eagerly awaited data on potential interactions between the comet's coma and the Martian atmosphere, setting the stage for novel insights into planetary-comet interactions. Despite its transient appearance, 3I Atlas serves as a cosmic laboratory for studying materials and conditions far from home. The comet's journey from the dense galactic disk, a region populated by some of the oldest stars, invites speculation about its age, possibly billions of years, and the processes shaping it. Such ancient origins make it a rare messenger from the galaxy's deep past, carrying with it the fingerprint of times long vanished. Scientists have begun extensive modeling to understand how interstellar objects like 3I Atlas form, survive, and travel through the hostile spaces between stars. These efforts integrate data on composition, trajectory, and activity, aiming to build comprehensive theories that may explain why some interstellar objects appear dust-laden and icy, while others like 3I Atlas hint at more complex and robust structures. The comet's passage emphasizes the dynamic and interconnected nature of our universe. It connects distant stellar systems by traveling millions of light-years, embodying a cosmic exchange that defies traditional static views. Objects such as 3I Atlas may be the carriers of material and information, migrating silently through the abyss and influencing nascent planetary systems as they pass. As the comet begins its departure, astronomers continue to analyze the troves of data collected, collaborating globally on observation campaigns, theoretical studies, and advanced simulations. The insights gained promise to refine models of solar system formation, interstellar chemistry, and planetary defense, bridging gaps across astrophysics disciplines. Beyond pure science, the extended observation of 3I Atlas acts as a catalyst for reflection on humanity's place in the cosmos. The fleeting beauty and mystery of this object remind us of our smallness amidst the vast and ancient universe, yet inspire hope that we, too, might one day traverse the stars or communicate with others out there. Through coordinated scientific dedication and international cooperation, the age of interstellar visitor research is just dawning. Each new comet or asteroid from beyond our solar system provides a treasure trove of information, expanding our understanding not only of the stars but of ourselves. 3I Atlas stands at the forefront of this exciting era. The true legacy of 3I Atlas may lie in what it represents, an invitation to embrace the unknown, to push the boundaries of science and exploration. With every observation captured, mystery deepens, encouraging new generations of scientists and dreamers to look skyward and question what else is out there, waiting to be found. This interstellar visitor's journey challenges us daily. Its velocity, composition, and activity are all riddles inviting answers. The continued pursuit of understanding 3I Atlas fuels innovation in telescopic technology, data analysis, and theoretical astrophysics. It promises discoveries that extend beyond itself, touching countless aspects of cosmic knowledge. In the advancing light of this visitor's passage, humanity stands united in curiosity and determination. 3I Atlas embodies the spirit of discovery, a reminder that the universe remains vast, vibrant, and filled with wonders yet unseen. Its path through our solar system marks a profound chapter in the unfolding story of human exploration and cosmic understanding. 3I Atlas's close approach to Mars in early October 2025 marked one of the most anticipated space events of the year, offering a rare chance to observe an interstellar object through the eyes of multiple Mars orbiters and rovers. On October 3, 2025, At approximately 30 million kilometers distance, the comet passed near the red planet, granting our robotic explorers an unprecedented viewpoint on a visitor from beyond our solar system. This event united the efforts of the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter with NASA's fleet, including the Mars Reconnaissance Orbiter and surface rovers Perseverance and Curiosity, each poised to gather critical data. Though Mark Twain once noted how the universe seemed to move in an orderly fashion, the encounter between 3I Atlas and Mars was anything but ordinary. The spacecraft circling Mars pointed their instruments not at the planet's surface, but outward, scanning the cold, dusty emissions forging the comet's tail, hoping to catch glimpses of its structure and composition hidden from Earth-bound telescopes obscured by solar glare. Using cameras originally designed to map Martian terrain, these orbiters struggled to capture detailed imagery due to the enormous distance but managed to detect the comet's expansive gas and dust halo with surprising clarity. Mars Express employed its high-resolution stereo camera to image the glowing tail, providing three-dimensional views that revealed the comet's wake stretching millions of kilometers into space. Meanwhile, the Trace Gas Orbiter focused on spectral analysis, utilizing advanced spectrometers to examine the chemical signatures emanating from 3I Atlas. Although the comet appeared as mere pixels across the camera's fields of view, every faint streak of light carried essential information about its volatile activity under increased solar radiation, offering fresh clues to its origins and evolution. On the Martian surface, the rovers Perseverance and Curiosity turned their attention to the sky, timing exposures to detect the subtle passage of 3I Atlas. Despite lacking specialized comet tracking equipment, their capable optical and spectroscopic instruments provided a rare ground-level perspective of an interstellar visitor, capturing changes in brightness and providing complementary data to orbital observations. This terrestrial perspective on Martian soil added depth and nuance to the comprehensive observation campaign. Scientists eagerly awaited the spectral data retrieved during the comet's closest pass, hoping it would reveal the relative abundances of water vapor, carbon monoxide, carbon dioxide, and other outgassed molecules. With the sun warming the comet's surface more strongly at this solar distance, the comet's activity likely reached its peak, potentially generating a denser, brighter coma and a longer, more luminous tail. Observations suggested that CO2 was a dominant volatile, sublimating vigorously even at distance, challenging traditional understandings of planetary physics. While data acquisition from Mars orbiters offered unprecedented insight, limitations remained. The vast scale of space ensured that even these sophisticated instruments could not resolve fine surface details, meaning the comet's true size and shape remained somewhat enigmatic. Despite these challenges, careful analysis of the light scattering and emission spectra suggested heterogeneous surface regions possibly composed of carbon-rich compounds intertwined with silicate and metallic elements, reinforcing the comet's exotic profile. These investigations also probed the plasma environment around 3I Atlas, exploring interactions between the solar wind and the comet's ion tail. The ion tail's morphology could reveal magnetic field orientations, charge exchange processes, and the comet's own magnetic influence, if any. Understanding these interactions enhances comprehension not only of comet behavior but also of broader heliospheric dynamics, how the Sun's influence extends and interacts with interstellar matter. The effects of 3I Atlas extended beyond mere observation. Its passage near Mars may have induced subtle energetic particle enhancements or transient magnetic field perturbations detectable by orbiters. While such phenomena would be minuscule compared to Martian natural processes, their detection would suggest that interstellar visitors can directly influence planetary environments, offering a window into the complex dance between objects across space. As 3I Atlas moved on toward its closest approach to the Sun, the Mars flyby marked a pivotal moment in its narrative, providing both a spatial vantage point and a scientific bridge connecting distant interstellar origins to our immediate solar environment. These observations formed part of a broader tapestry of data, informing models predicting the comet's behavior in the intense solar heat about to envelop it. Looking beyond Mars, plans to observe 3I Atlas at Jupiter are underway, with the European Space Agency's Jupiter Icy Moons Explorer (JUICE) mission scheduled to capture data during the comet's November passage near the gas giant. Jupiter's immense gravitational influence could alter the comet's trajectory, introducing additional variables into the cosmic journey that scientists strive to understand. JUICE, equipped with powerful cameras and spectrometers, promises perhaps the most detailed glimpse yet, particularly as the comet's activity is expected to escalate near perihelion. The Jupiter encounter offers unique potential for real-time studies of how large planetary magnetospheres interact with robust cometary tails. The combination of JUICE's instruments and NASA's Europa Clipper mission, both operating nearby, allows for coordinated observations unprecedented in cometary science. These coordinated efforts could reveal new mechanisms of particle acceleration, plasma interactions, and the physics of transient celestial phenomena. Meanwhile, Earth-based observations will pick up again once 3I Atlas reappears from behind the Sun in early December 2025. By then, the comet will be receding, giving scientists a chance to record the waning phases of activity and the gradual dispersal of the comet's dust and gas. This fading light closes a brief chapter on a remarkable interstellar journey but opens new realms of discovery through the analysis of accumulated data. Scientists are especially intrigued by the delicate balance of solid and gaseous components within 3I Atlas, with its icy surface believed to mask a complex, structured core. The nucleus might harbor layers of processed materials, perhaps the result of cosmic radiation and countless star system passages. If artificial technology is present within, as some speculate, its internal mechanisms must be resistant to cosmic degradation, raising profound engineering questions beyond existing human expertise. These wide-ranging analyses continue to fuel discussion and speculation in scientific and public forums alike. Some see 3I Atlas as a cosmic messenger, delivering materials or information across vast interstellar distances. Others urge caution, emphasizing the need for rigor and evidence before embracing extraordinary conclusions. Regardless, this mysterious traveler sharpens human appetite for cosmic discovery, reminding us of the universe's boundless complexity. As scientific facilities push their limits and new methodologies arise, 3I Atlas offers an unparalleled testbed for innovation. The intersection of observation, theory, and computational modeling exemplifies how contemporary science approaches unknown phenomena not with certainty but with open inquiry and relentless pursuit. This cosmic visitor inspires a synthesis of curiosity, skepticism, and hope. In these moments, humanity's collective gaze turns skyward, uniting professional scientists, policymakers, and the general public in shared wonder. The narrative of 3I Atlas extends beyond raw data and equations. It embodies our desire to connect with the cosmos and comprehend our place within it. This interstellar wanderer stirs age-old questions anew: what else lies waiting among the stars, and how shall we respond when next the universe whispers its secrets close to home? 3I Atlas S passage is a fleeting glimpse of cosmic vastness made intimate through technology and endeavor. As it speeds outward after its solar system transit, the comet leaves behind a trail of dust, questions, and inspiration. It challenges existing paradigms and invites humanity to imagine, innovate, and explore with humble fascination. The echoes of its journey will resonate for decades, weaving into the fabric of human knowledge and aspiration. We stand on the horizon of a new era where interstellar objects like 3I Atlas cease to be anomalies. Instead, they become embedded in the broader context of understanding our galaxy's dynamic exchange, guiding our advancement into deeper space and revealing the universe's profound complexity. This visitor from the stars thus becomes a bridge between worlds, between past and future, and between the known and the unknowable. 3I Atlas approached its closest point to the Sun, perihelion, on October 29, 2025, at approximately 1.36 astronomical units, roughly 203 million kilometers from our star. This distance places it between the orbits of Earth and Mars, a perfect position to observe how an interstellar object behaves under the Sun's warming influence without venturing too close. At perihelion, the comet was moving with maximum velocity relative to the Sun, about 68 kilometers per second, an incredible speed that underscored its alien origin and hyperbolic orbit. As it neared perihelion, 3I Atlas's solar elongation, its angular distance from the Sun as seen from Earth, shrunk dramatically. This meant the comet was increasingly hidden by the Sun's glaring brightness, making Earth-based observations difficult or impossible from October 1 to November 9. During this time, the comet passed behind the Sun in the line of sight from Earth, obscured from view in a phase known as solar conjunction. However, space probes positioned elsewhere, including orbiters around Mars and the spacecraft en route to Jupiter, maintained visual and spectroscopic vigilance on the comet. The approach to perihelion triggered heightened activity on 3I Atlas's surface, driven by intense solar heating. Complex volatile ices began sublimating rapidly, releasing gases that formed the thick coma, an extended tail observed before and after the closest Sun approach. Remote sensing from instruments aboard Mars Express and NASA's Mars orbiters scrutinized these emissions, noting increases in carbon dioxide and carbon monoxide outgassing. These volatiles outpaced water vapor release, an atypical pattern for comets familiar to our solar system. Telescopes such as the Hubble and James Webb Space Telescopes captured diminished light signatures due to reduced solar elongation, but data collected before and after perihelion revealed fascinating changes. Analysts noted a reddening of the comet's color spectrum, possibly due to the exposure of new materials on the comet's surface or the release of complex organic compounds disrupted by solar heating. These dynamic changes suggested that 3I Atlas's surface was not uniform but rather a complex mosaic influenced by prolonged exposure to interstellar environments. The short observational window during perihelion posed a challenge but also an opportunity. The comet's increased activity made it highly informative for scientists despite limited visibility. Instruments onboard orbital platforms seized on this moment to measure the composition of gases and dust particles released, analyzing isotopic ratios that provide clues to its formation history and interstellar journey. These measurements are essential to understanding whether 3I Atlas carries signatures of natural cosmic processes or evidence of technology. Continued analysis indicated that the comet's sublimation was irregular and episodic, with sudden jets potentially altering its rotation and trajectory. These outbursts hinted at subsurface pockets of gas trapped beneath dusty layers, releasing powerfully when heated, causing the nucleus to eject material in spurts. Variations in brightness and tail morphology offered indirect evidence of nucleus shape and surface heterogeneity, adding spatial texture to our view of this wandering giant. Data also suggested electromagnetic interactions between the comet's outgassed ions and the solar wind, creating an ion tail affected by magnetic fields. This interplay produced plasma waves and auroral-like phenomena observable by space-based instruments, making 3I Atlas a natural laboratory for studying plasma physics in an interstellar context. Its behavior under solar influence continues to inform our understanding of solar-comet interactions on a new scale. Meanwhile, the comet's high velocity and position continued to pose modeling challenges. Scientists worked to refine simulations incorporating the effects of solar gravity, radiation pressure, and any non-gravitational forces acting upon the comet, such as outgassing thrusts. These models aim to predict 3I Atlas's future path through the solar system with greater accuracy, informing subsequent observation opportunities and potential missions. Beyond physical science, the perihelion passage of 3I Atlas stirred intense international interest and collaboration. Agencies such as ESA and NASA coordinated observation campaigns involving spacecraft, telescopes, and even amateur astronomers with large backyard telescopes worldwide. This collective effort demonstrated the growing priority and excitement surrounding interstellar objects, which once seemed mythical but now appear as tangible sources of knowledge. Public engagement soared in anticipation of and following the perihelion event, with live streams, educational broadcasts, and expert commentary making the comet a focal point for science communication. This surge in public interest not only inspired wonder but also highlighted the role of such phenomena in bridging public understanding with cutting-edge research, affirming astronomy as a democratic and universal pursuit. As 3I Atlas passed perihelion and began its outbound journey, the comet lingered in the solar system's inner region for a few weeks, visible to earthbound telescopes at dawn and dusk. Its brightness faded, measured at magnitude 12 to 13, before dropping beyond magnitude 14 as it slipped into deeper space. Observers tracked these fading phases, noting tail morphology and gas composition decline, crystallizing a comprehensive timeline of cometary activity influenced by solar proximity. This gradual departure emphasized the transient nature of interstellar visitors and the finite window granted for study. Even as 3I Atlas disappeared from visible range, the rich data infrared spectra, images, plasma measurements collected at and after perihelion would fuel analysis and theoretical modeling for years to come. These efforts promised to unravel further the mysteries encoded in its ancient, interstellar journey. The comet's perihelion phase also served to test human responsiveness in observational astronomy. Coordinating multiple instruments amid narrow visibility underscored current scientific capabilities and highlighted gaps for future technological development. It spurred initiatives calling for dedicated spacecraft designed to rapidly react to and study such fleeting interstellar phenomena with greater proximity and detail. In hindsight, 3I Atlas's passage near the Sun underscored the essential role of space-based observation in modern astronomy. Without orbiting telescopes and planetary probes positioned away from Earth's atmospheric disturbances and solar glare, much of the comet's activity during this crucial phase would have gone unnoticed. These assets are fundamental to understanding and responding to cosmic events where time is limited. Scientists speculate about the after-effects of perihelion on 3I Atlas's structural integrity. Close proximity to solar heat may have triggered fractures or reshaping of the nucleus. Such structural changes could explain some of the observed outbursts and abrupt increases in dust production, suggesting an evolving physical state actively responding to extreme radiative forces. Long-term monitoring of 3I Atlas continues to provide a rare snapshot of an interstellar visitor's dynamism under stellar influence. Its journey from galactic background to solar flare illuminates processes common throughout the universe yet rarely accessible for direct observation. Thus, each episode of activity, no matter how brief, significantly enriches our cosmic understanding. Reflecting on these events evokes philosophical contemplation. The comet, a messenger from a distant star, reveals both the vastness of our universe and the preciousness of these fleeting moments of insight. Humanity's gaze continues to stretch into space, driven by curiosity and the inexorable desire to comprehend our origins and fate amid the stars. The perihelion serves as a fulcrum pivoting the comet from an approach to a departure. Scientists now focus on how 3I Atlas transitions from an object activated by solar warmth to a dormant traveler, but one laden with new mysteries and lessons gleaned along the way. Every stage of its voyage deepens the story inscribed in cosmic history. This chapter in 3I Atlas's passage invites reflection on how future interstellar encounters might be observed and understood. The synergy between Earth-based, orbital, and planetary instruments sets a precedent for astronomy's multifaceted approach, necessary for capturing transient phenomena occurring on cosmic scales yet within our observational grasp. Future missions with advanced technology may capitalize on the knowledge gained during 3I Atlas's perihelion passage. Proposals for intercepting or closely following interstellar objects rely heavily on data from these natural experiments, guiding spacecraft design, trajectory planning, and scientific instrumentation for optimal exploration. Our expanding toolkit in space exploration and observation prepares us for the unknown, where objects like 3I Atlas carry not only materials but potential messages and phenomena beyond human experience. The perihelion passage stands as a landmark event, highlighting how far we've come and how much more lies ahead in cosmic discovery. In the end, 3I Atlas's closest approach to the Sun is more than a celestial event, it is a vivid reminder of the delicate balance between known physical laws and cosmic mysteries. It underscores humanity's ongoing quest to observe, understand, and ultimately connect with the broader universe, a journey marked by wonder, challenge, and profound inspiration. As the comet retreats into darkness, the observatories turn their attention to new horizons, eager to track the trail this traveler leaves behind. Every stage of 3I Atlas's journey enriches our cosmic perspective, inviting us to imagine the vast interstellar highways it has traversed and what legacies it may carry onward into the stars. 3I Atlas's journey out of the solar system after perihelion is a testament to the transient yet profound nature of such cosmic visitors. With its closest approach to the Sun behind it, the comet now begins a slow retreat, moving away from the intense solar radiation that had temporarily awakened it. During this outbound leg, scientists are afforded crucial opportunities to observe how an interstellar comet gradually fades, cooling and releasing less material as it journeys back into the dark void of space. The changes in cometary activity post-perihelion offer a unique window into its physical and chemical nature. Infrared observatories continue to track the gradual reduction in gas emissions and dust production, revealing how volatile compounds, once quickly sublimated near the Sun, now diminish or freeze back onto its surface. This cooling phase enhances understanding of the comet's reservoirs of ices, which likely froze billions of years ago in far-flung star systems far beyond our solar sphere. Ground-based telescopes positioned across the globe collaborate to monitor the progressive dimming of 3I Atlas S coma and tail. Throughout November and December 2025, as the comet journeys through the constellations Virgo and Leo, it fades from view, descending from magnitude 11 at perihelion to dimmer than magnitude 12 toward year's end. Such data are key to modeling dust particle size, composition, and ejection rates, building a timeline of the comet's energy budget and activity levels. As 3I Atlas distances itself, the composition of its fading tail remains a subject of intense scrutiny. Debris particles scattered in its wake traverse the heliosphere, interacting subtly with solar wind and magnetic fields, creating a natural laboratory for space plasma studies. These interactions inform broader astrophysical models, shedding light on the environment around our Sun and the forces shaping small bodies in space. Long-term observation campaigns also seek to understand the comet's trajectory and velocity alterations during and after perihelion. Scientists have noted subtle deviations in its motion consistent with outgassing jets and possible rotational spin changes. These physical dynamics underscore the complexity of interstellar objects, whose behaviors combine intrinsic properties with environmental effects, challenging simplistic orbital predictions. As 3I Atlas recedes, it passes within about 1.8 astronomical units from Earth in December 2025, offering a second phase of observation from our planet after it emerges from solar conjunction. Although the comet will be relatively faint, advanced telescopes equipped with sensitive imaging and spectroscopic instruments will seize this opportunity to extend their study. Amateur astronomers and citizen scientists are encouraged to join the observational efforts, contributing valuable data to global databases tracking the comet's trajectory and brightness. The outward journey of 3I Atlas is not solely about waning activity, it presents the potential for surprises. Sudden bursts or fragmentation events common in comets passing close to the Sun could occur. Scientists remain vigilant for such phenomena, which might reveal internal structure, volatile pockets, or mechanical stresses induced by thermal shocks and tidal forces. The comet's tail, shaped by interactions with the Sun's radiation and magnetic environment, acts as a visible signature of ongoing sublimation and particle release. Observing the tail's geometry, length, and brightness informs models of particle size distribution and dust ejection velocity. These parameters distinguish 3I Atlas from typical solar system comets, contributing to ongoing debates about its origin and nature. Spectroscopic analyses during the outbound phase focus on tracing molecular abundance trends. The relative amounts of carbon dioxide, carbon monoxide, and complex organic molecules diminish at varying rates, offering insights into the layers composing the nucleus and the mechanisms regulating outgassing. These chemical fingerprints suggest a nucleus composed of heterogeneous material, possibly with layered or patchy composition reflecting its interstellar past. In March 2026, 3I Atlas is scheduled for a distant flyby of Jupiter, passing about 0.36 astronomical units from the giant planet. Jupiter's massive gravity is expected to alter the comet's trajectory modestly, providing a natural experiment in gravitational dynamics of interstellar objects within the solar system. This encounter will be closely monitored to adjust models predicting the comet's future path beyond. The collaboration between ESA's Jupiter Icy Moons Explorer, JUICE, mission and NASA's Europa Clipper offers an unprecedented opportunity to combine high-resolution imaging and spectrometry from multiple platforms. This coordinated approach aims to capture the comet's behavior during the Jupiter approach, clarifying changes in outgassing, tail morphology, and particle composition under the influence of Jupiter's gravity and magnetosphere. These observations promise to improve our understanding of how planetary environments modify or affect cometary behavior during close approaches. Jupiter's intense magnetic environment might induce changes in ion tail dynamics, enhancing particle acceleration and plasma interactions. Studying these effects has implications not only for comet science but also for understanding the space weather conditions near giant planets. As it moves ever further from the Sun and the Earth, 3I Atlas enters the vast stretches of space where sunlight weakens, and the environment reverts to interstellar conditions. In this cold, dark realm, the comet's activity is expected to drop sharply, with most volatiles freezing back onto its surface, rendering it largely inert once more. Observations during this cooling-off period provide concluding chapters to the comet's solar encounter and valuable insight into the resilience of interstellar objects in space. Beyond physical study, the retreat of 3I Atlas emphasizes philosophical considerations about the fleeting nature of such cosmic visits. This visitor, arriving from distant star systems, shares its story briefly before vanishing into the cold interstellar void again. Its passage reminds humanity of its small but inquisitive role in a vast, continuously evolving universe filled with mysteries waiting to be uncovered. The long-term tracking of 3I Atlas's outbound path contributes to understanding interstellar object populations and possible connections to their parent stars. By analyzing its speed, trajectory, and composition, scientists hope to map histories extending billions of years, connecting the comet to broader narratives of stellar and galactic evolution. Emerging questions about the nature of 3I Atlas's origin gain fresh momentum. Is it remnant debris from an ancient supernova, a fragment of a disrupted exoplanet, or perhaps a relic spacecraft past its mission? Each possibility carries extraordinary implications for astrophysics and the search for extraterrestrial intelligence, broadening the scope of inquiry well beyond traditional cometary science. The comet's enduring legacy lies in the scientific, cultural, and technological vigor it inspires. It catalyzes advances in observational technology, encourages international collaboration, and captures the public imagination. Documentaries, research papers, and educational projects all reflect the deep human fascination sparked by this distant visitor. Looking ahead, 3I Atlas's passage serves as a pilot study for future encounters. Learning how to rapidly identify, track, and interpret interstellar objects will enhance humanity's capability to explore, protect, and understand our solar system and its place in the galaxy. It encourages the development of specialized space missions tasked with intercepting such visitors, heralding a new era in space exploration. Fundamental questions persist about the physical processes powering 3I Atlas's activity and its response to solar heating. Understanding sublimation dynamics, dust lifting mechanisms, and nuclear structural integrity is essential to broader cometary science. The peculiarities of 3I Atlas challenge classical models, pushing researchers to refine or redefine theories. As distant probes and telescopes continue to send data back to Earth, the trove of knowledge grows. Every spectroscopic line, dust particle count, and light curve graph expands humanity's grasp of cosmic chemistry and physics. Insight gained from 3I Atlas's journey enriches understanding of both our neighborhood and other star systems. Scientific efforts now focus on integrating the data gathered with broader astrophysical frameworks. The comet's behavior informs models of star system evolution, interstellar medium composition, and the mechanisms by which matter moves through the galaxy. Such integrative science showcases the interconnectedness of cosmic phenomena. The community of scientists, fueled by perseverance and collaboration, embodies hope and determination. They navigate uncertainties and conflicting data with rigor and creativity. This endeavor exemplifies human curiosity and the relentless pursuit of knowledge in the face of the universe's grandeur and complexity. As 3I Atlas continues its outbound voyage, it leaves behind a beacon of discovery and inspiration. The comet's story, etched in light, dust, and science, invites humanity to look skyward and dream of the vast cosmic highway stretching across the stars, an endless frontier of mysteries beckoning exploration and wonder. Welcome, dear listeners, to the final chapter of our journey with 3I Atlas, one of the most enigmatic visitors our solar system has ever witnessed. Over the past months, we together unraveled the mysteries of this interstellar wanderer, exploring its vast size, unusual composition, mysterious accelerations, and intriguing interactions with planets like Mars and Jupiter. As 3I Atlas recedes into the starry depths from which it came, it leaves behind a legacy filled with questions that push the boundaries of human knowledge and ignite our cosmic imagination. As 3I Atlas ventures away from the Sun after passing its perihelion on October 29, 2025, scientists continue to monitor the fading glow of its coma and tail, the telltale signs of cometary activity gradually decreasing. Its journey outward reveals how the warm embrace of our star temporarily ignited volatile gases and dust, a delicate dance of sublimation that unveils the inner makeup of this ancient traveler. Despite dimming, each photon captured tells a story, each spectroscopic line shines a light on the chemical processes at play, allowing us to peer into time capsules forged billions of years ago in distant star systems. With an abundance of carbon monoxide, carbon dioxide, trace water ice, and complex organic molecules streaming into space, we begin to sketch 3I Atlas's history and physical nature. What kind of environments forged this comet? How have cosmic rays and stellar winds sculpted its surface over untold eons? Answers to these questions facilitate a broader understanding of interstellar medium chemistry and the movement of matter across galaxies, enriching fields far beyond cometary science. As it fades into the vast celestial ocean, 3I Atlas's path continues to be influenced by the massive gravity wells of gas giants. Notably, it will pass near Jupiter in March 2026, a close encounter that could alter its trajectory, shape, or structure in subtle but significant ways. This gravitational interplay provides a natural laboratory to study the physical and mechanical responses of interstellar objects to planetary forces, informing models of comet and asteroid behavior influenced by large bodies within solar systems. International space missions, including ESA's JUICE and NASA's Europa Clipper, are poised to capitalize on this rare opportunity, preparing instruments to track the comet's behavior during its Jovian flyby. These missions promise unparalleled data on how distant bodies interact with diverse planetary environments, extending insights gained from Mars flybys and Earth-based observations. The synchronization of these missions exemplifies humanity's spirit of exploration, transcending borders in pursuit of knowledge. Meanwhile, Earth-based observatories prepare for a final observational window as 3I Atlas moves beyond the glare of the Sun and becomes faintly visible once again in the pre-dawn skies of late 2025 and early 2026. Though its brightness diminishes, the comet remains an object of intense scientific scrutiny. high-aperture telescopes and networks of astronomers ready themselves to capture any faint glimmers of residual activity or fragmentation events that may narrate the comet's ongoing evolution. Throughout 2026, 3I Atlas will gradually disappear into the darkness of interstellar space, beyond the gravitational clutch of our solar system, a wandering relic of cosmic history. Its departure marks the conclusion of a brief but transformative spectacle, highlighting both the richness and the ephemerality of interstellar visitors. Each piece of data gathered feeds into an ever-growing mosaic of understanding, shaping humanity's grasp on the immense complexity of the cosmos. Beyond the physical science, 3I Atlas's passage invites deep reflection on humanity's cosmic context. This visitor, ancient and unbound, reminds us of our small but deeply inquisitive place within the grand theater of the universe. It challenges us to expand our vision, to embrace discovery and mystery alike, and to contemplate the possibility of other worlds, life forms, and civilizations drifting silently through the depths of interstellar space. Scientists ponder broader questions inspired by the comet's journey. Is 3I Atlas unique, or are countless such travelers weaving through the galaxy, unnoticed until we learn to find them? What role might these interstellar objects play in seeding life, spreading organic molecules, or perhaps transmitting information across light years? These questions propel interdisciplinary research uniting astrophysics, chemistry, biology, and even information science. The public fascination with 3I Atlas mirrors these scientific wonders. Schools, museums, planetariums, and media outlets worldwide have joined in celebrating this cosmic guest, turning the event into a shared human experience. Through documentaries, lectures, and interactive platforms, the story of 3I Atlas transcends scientific data charts, drawing everyday people into the collective quest for cosmic understanding. In the realm of future exploration, 3I Atlas has galvanized efforts to develop rapid response missions capable of rendezvousing with interstellar visitors. Although this comet itself left the solar system too quickly for interception, its detailed study lays technical and scientific groundwork. Engineers and scientists collaborate in imagining spacecraft equipped to chase these celestial runners or even capture samples, opening a bold new chapter in humanity's planetary and galactic exploration. Reflecting on this comet's journey from discovery to disappearance is a humbling experience. It is a vivid reminder of the vast, interconnected cosmic web through which matter, possibly life itself, journeys between stars. 3I Atlas embodies the enduring enigmas of existence, the beauty of curiosity, and the relentless human drive to comprehend the unfathomable. Dear listeners, as we conclude this odyssey through the mysteries of 3I Atlas, we stand in awe of the universe's ability to astonish and inspire. From a faint dot discovered on a remote mountain to a colossal traveler passing in our cosmic backyard, this comet has opened doors to new realms of wonder. Its story is a beacon encouraging us to keep looking up, keep questioning, and keep dreaming. Thank you for joining me on this incredible voyage across time and space. Until we meet again under the great canopy of stars, may curiosity and wonder guide you always. Good night, and keep your eyes and mind open to the universe's endless secrets.